What if a self-driving car could practice millions of dangerous situations without ever leaving the garage? Inside entire cities, storms, traffic jams, or even collapsing bridges created instantly by AI from a single prompt? As crazy as it sounds, this already exists. It's called Genie 3, and it might quietly become one of the most important AI systems ever developed. Built by Google DeepMind, Genie 3 is a powerful generative AI system that can run full virtual worlds in real time. But what happens when you take a system like that and plug it into a self-driving car company? You get something that can train autonomous vehicles in ways the real world simply can't. Waymo, Google's self-driving division, is already using Genie 3 to create ultra-realistic driving simulations. Traditionally, self-driving systems depended on millions of miles of recorded road data or hand-built simulations. That worked, but it had limits. Rare situations, like extreme weather, unpredictable pedestrians, or chaotic traffic, were hard to capture. Genie 3 changes that completely. It takes Waymo's massive sensor data from cameras, LiDAR, and radar and generates entirely new driving scenarios in seconds. Foggy intersections, sudden animal crossings, or strange traffic patterns can all be created instantly, with lighting and object behavior that still feel realistic. But these simulations aren't just video. Genie 3 actually produces full multi-sensor environments. That means synchronized camera feeds, LiDAR point clouds, and radar signals, all matching what the real car hardware would see. Waymo calls this the Waymo World Model, and it allows their driving software to treat the simulation exactly like the real world. So the system can practice handling rare events, like a child running into the street, without anyone being in danger. And because Genie 3 runs in real time, engineers can simply type something like a rainy night with sudden construction barriers, and the system generates a complete controllable world on the spot. So what's the real impact of all this simulated driving? It dramatically speeds up development and improves safety. Instead of waiting years for rare situations to happen on real roads, Waymo can train for them instantly. That means faster software updates, better decision-making, and more confidence when deploying self-driving cars in new cities. Now, at its core, Genie 3 works like a world generator that thinks one frame at a time. Technically, it's what researchers call an autoregressive world model. But in simple terms, imagine an AI that builds a scene the way a video game engine would. Except it isn't using traditional 3D models. Instead, it predicts each frame based on the last one, creating the illusion of a fully interactive 3D world. It was trained on massive amounts of video from the internet, so it naturally picked up the rules of the real world. Things like gravity, water movement, lighting, and how materials react. But what makes Genie 3 different from other AI video generators? It doesn't just create clips you watch. It creates worlds you can move inside. Unlike tools such as Sora or Veo that simply play out a clip in front of you, Genie 3 feels more like a place you can actually step into. You're not just watching, you're moving. You can walk forward, turn corners, look around, and the world reacts immediately, running smoothly at 24 frames per second. And it doesn't stop there. While the scene is already in motion, you can change it on the fly. Type something like "bring in a lightning storm" or "add a flock of birds," and the environment shifts naturally without breaking the flow or the physics. And this is where things really start to click. Genie 3 remembers its world. If you pass a red car parked on the street, wander off for a bit, and later come back the same way, the car is still sitting there. The world doesn't reset or fake it. It holds onto details the way real places do. That long-term consistency is exactly why DeepMind sees Genie 3 as a base for future AI systems that learn by exploring, not just observing. Okay, so the world looks convincing, but do they actually behave like the real world? Turns out they do. Genie 3 handles physical details incredibly well. Water splashes naturally, reflections shift as lightning changes, shadows move over time, and even soft surfaces respond to movement. Entire ecosystems can emerge. Forests full of rustling leaves, animals moving together as groups, or crowded city streets where people flow around each other naturally. And for self-driving cars, this level of realism means rain on windshields, slippery roads, and flying debris can all be tested safely, long before a real car ever faces them. But what's the real advantage here? It lets engineers test what-if scenarios that would be impossible, or too dangerous, in real life. A sudden storm or chaotic traffic situations can all be simulated instantly. That means smarter AI, faster development, and safer systems before they ever touch a real road. Instead of scripted animations, Genie 3 learns how physics works by studying huge amounts of real video. So when it generates a scene, things don't just move, they react naturally to the environment. So what does realistic physics actually look like inside an AI-generated world? Imagine a tropical beach at sunset. Waves do not loop like a video game of the 80s. They hit the rocks, create foam, and later dissolve gradually into the sea. The movement varies with the wind, the light varies with the setting of the sun, and the reflections on wet sand are in real time. Even small details matter. Footprints remain in the sand, and then over time, they disappear as the wind and movement alter the terrain. Lighting also reacts in a realistic manner. The shadows are lengthened when the sun is setting. The rays of light penetrate the clouds, and the materials such as skin or leaves are slightly glowing as the light is reflected through them. In a forest, the separate leaves go with the wind, branches swing, and animals go in herds without colliding. In cities, people walk around the barriers and observe the personal space as real crowds do. But why does all this detail matter for self-driving? Because those tiny physical details are exactly what real cars have to deal with. Genie 3 can simulate rain hitting a windshield, droplets merging together, and wipers leaving streaks that distort visibility. It can model tires losing grip on wet roads or debris blowing across lanes during construction. These aren't just visuals. The physics actually affect how the virtual car sees and reacts. And then comes the real advantage. The system can create extreme, rare situations. A bridge collapsing mid-drive, a sudden sinkhole, or debris flying through the air can all be simulated safely. Engineers can run millions of these black swan events, training the AI to stay calm and make the right decision. Now, what if you could change the world while you're inside it? That's where Genie 3's promptable interactivity comes in. You can type a command like earthquake starts and the environment reacts instantly. Buildings sway, windows shatter, cars lose traction, and pedestrians stumble, all while you keep control of the camera or vehicle. Weather can shift from sunny to hailstorms in seconds. Roads turn icy, trees fall across lanes, and traffic reacts in real time. For Waymo, this kind of interactivity is a goldmine. Engineers can test scenarios like a flock of birds landing on the highway or aggressive drivers during rush hour. Each change creates new chain reactions, helping the AI learn to predict and avoid danger. And one of the most exciting parts is how it opens the door to animation and creative storytelling. Instead of only generating lifelike scenes, it can also build stylized cartoon-like worlds that feel alive and expressive. All it takes is a simple prompt, like a cartoon fox chasing rabbits through an enchanted forest, and Genie 3 creates a fluid, animated scene filled with personality. But can an AI really capture the charm and emotion of classic cartoons? Surprisingly, yes. Genie 3 understands motion styles like squash and stretch, exaggerated expressions, and bouncy movements. The fox might smirk mischievously while the rabbits dart around with wide, panicked eyes. And the best part is consistency. Characters keep their personality and behavior across scenes, instead of resetting every few seconds like older models. This makes it incredibly useful for game developers and filmmakers. Instead of spending months building assets, a developer can quickly test a level set on floating islands or inside a neon cyberpunk city. Directors can storyboard entire action scenes or dreamlike sequences in real time, adjusting lighting, camera angles, or environments on the fly. But how does this creative side actually help real-world AI systems? It lets engineers simulate unpredictable behavior. For example, in a Waymo-style scenario, Genie 3 could create cartoonish pedestrians who skip, bounce, or move in unusual patterns. It could simulate animals leaping across highways in exaggerated arcs. These strange physics-based distractions help train self-driving systems to handle the unexpected, making them safer in chaotic real-world situations. Now, all of this creativity is powered by some serious technical muscle. Genie 3 runs at 720p resolution and 24 frames per second, which gives it a smooth, real-time feel. More importantly, it can maintain consistent worlds for several minutes at a time, something earlier versions struggled with. That means you can explore an entire virtual city without the environment glitching or forgetting objects you passed earlier. It was trained on massive amounts of video, learning how gravity, lighting, and collisions work, then refined to respond to user commands. And companies like Waymo can fine-tune it further using their own sensor data, turning it into a specialized training environment for autonomous vehicles. So what does this all mean for the future? It could completely change how AI systems are built. Instead of spending billions collecting real-world data, companies can generate endless training scenarios on demand. Rare events, like sudden floods or sensor-blinding sunlight, can be tested instantly. That speeds up development, cuts costs, and improves safety. So what do you think? Would you trust a self-driving car trained inside an AI-generated world? Could systems like Genie 3 actually make roads safer? Or does it sound a little too sci-fi to be comfortable? Drop your thoughts in the comments. And hey, if you are the kind of person who'd happily explore an AI-made world instead of sitting in traffic, hit that subscribe button. Your future robot driver might be watching.